All right, today we are doing section 3.7 in the Green Book, Transforming Formulas. You're doing page 143, number 1 through 34 odd. And vocabulary we'll be using is properties of equality, the denominator, clearing the denominator, inverse operations. Having a lot of problems with what kids were doing on 3.6 that they were not showing the parentheses, so I'm going to talk about that. All right, let's take a minute and do the problem by clearing the denominator. I want you to clear the denominator. All right, let's check our work. Since I already have a couple parentheses on both sides, I'm going to use brackets. Okay. Now, one thing I want you to make sure is that when you number it, that you have enough room next to it so that you can actually do some work. Don't squish this in. This is very important. So I'm going to take a big bracket and my least common denominator is 6. And we're multiplying both sides. Now this is what I'm not seeing, is that both sides are in the parentheses. I'm seeing people put their parentheses only on, like, say, the 6. And they're not doing this. And then putting a 6 here. Now the problem with that is that's not correct math. What that means in math is that you have the ability to multiply 6 times what's next to it, 8, and that's it. And 6 times what's next to it, this term right here. So you need to stop doing that. You have to put the parentheses around both whole sides. The other thing I wanted to show you is I wanted to talk about how many terms. So here's a term. This is tied together by multiplication, so that's a term. Here's a term. Here's a term. So there's 4 terms here that I have to multiply that 6 by. Okay, so I'm putting the parentheses around the whole side and multiplying by 6. Both sides, right? Okay, now on the first term, we know that I'm going to get 48. And then on the second term, which is this whole thing right here, it's tied together by multiplication, the 3 goes into 3, and I'm going to line that up a little bit better with the numerator. That's another thing people are getting really lazy with. Okay? 6 goes into 3, 3 goes into 6, 3 goes into 3 once, and into 6 twice. So 2 times this quantity is minus 4 times that quantity, minus m. Okay, I'm distributing again all the way over to the 14. So 6 times 4 is 24. Carry the 2, 6, 7, 8, 84. And now I'm distributing over here. 2 goes into 2 once and into 6 3 times. So we have a minus. 3 times 1 is 3, and then everything else, m minus 4 times m plus 5. Now we have some distributing to do. Okay, let's get rid of the distributing within the distributing right here. And that becomes minus 4m, and this becomes minus 20. And I can do the rest of my distributing. 48 minus, I've got that m. I can do this distributing, so it's negative 20, and then negative 4 times negative m is plus 4m equals 84 minus 3. I'm not distributing that at this time because I had to first clear out inside. Now I'm going to distribute it. Everything else I'm going to write down, right? I'll bring the 48 down, minus 20. I could combine my like terms there on that side. So this side's a little bit ahead. So that would be 28. Equals 84. I can't combine like terms until I finish the distributing here. Minus 3m plus negative times negative makes a positive plus 12m. And negative 3 times negative 20 is plus 60. Now, I've already combined like terms here. I can combine them here. So that makes a 9m. And 84 and 60 make plus 144. Now, remember we're moving our m's to keep them positive. So I'm going to subtract 4m, get all the m's to one side. 28 equals 5m plus 144. I'm subtracting my constant terms, moving it to the left. Be careful, 144 minus 28. Let's see, that's 14 minus 8 is 6. And it becomes a 3, so that's a 1. And I'm bringing down the 1. So it's 116. And it's negative because it takes the sign of the bigger number. Divide both sides by 5. And m is equal to negative 116 over 5. Okay? 116 over 5. So a couple things here I want you to pay attention to. Notice that I'm putting a parenthesis around the whole side. I need to see that. If you don't, I will not count your homework. So if I gave you a 0, you can just go in and fix it and make it a little bit clearer, not redo the whole thing. Make sure you are lining up your 6 with the numerator fractions. This should be on the line of the paper. Okay, let's see if I don't even know if I have. Oh, yes, I do. So I got the right. There we go. Much cleaner. All right, pause the recording if you would like to keep this. All right, so today we are, again, 3-7 is our objective. Homework is 3-7, page 143, 1 through 34 odd. Our vocabulary is the same, properties of equality. You also might hear the terminology in terms of. In terms of. A is given in terms of. So we're going to talk about that phrase. So my quotations should go right here. Okay. All right, let's go. So basically, we are going to continue with our inverse operations. Only now we're just doing inverse operations with formulas. Okay. We're not solving anything. We're solving for we're not solving for a number. We're solving for a variable. So now what this means is the little colon right here means solve for t. That means get t alone. So we write down, do you know what this formula is? It's rate times time equals distance. So I'm trying to get that t all by itself. So since it's multiplied, the r is multiplied, I have to do the inverse operation. To do the inverse operation and divide by r. And then t is equal to distance over rate. So now t is given in terms of d and r, is the language that we use. T is given in terms of d and r. All right, next one. Force equals mass times acceleration. You don't have to memorize that because they're telling us just solve for the A. So you try it. Now check your work. We start with force equals mass times acceleration. Right now, F is given in terms of M and A. Okay, once we start and we get A alone, since it's multiplication, we have to divide by what we want to get rid of, M, and I get F over M is equal to A. and we flip it around and say A is given in terms of F and M. Okay, now, very important that you cover all these steps. Do not flip it around to the end. Also, I want you to notice it's a capital F and a little a and a little m. You need to keep them in the same, if they're lowercase, you need to keep them lowercase. If they're uppercase, keep them uppercase, because they represent different things. Capital F represents force. Little b means the base line of a triangle, but big means the base area of a three-dimensional shape. Okay, so now A is given in terms of F and M. Now we're solving for H. Right now A is given in terms of B and H. We're going to switch it around so we have H in terms of B and A. Okay, now the first thing we're going to do is get rid of that fraction. A equals 1/2 BH. So the same way, we are going to be clearing both sides by multiplying by 2, right? You could do 2 over 1, but 2. All we need to really do is the denominator, okay? And you see when I distribute here, it's all one term because it's multiplication. I'm left with BH. And over here, I'm left with 2 capital A. Now we want to get H. So what would we do? Since this means multiplication, we are going to divide by little b. H equals 2A over little b. Or I can say H is equal to 2A over little b. Now H is given in terms of A and B. All right, pause that if you want to, or go back and pause it. Does anybody know what this formula is? This is area of a triangle. Okay, next formula, anybody know? Let's just say it's volume, and it's of something round. So this is volume of a cone, because pi represents the circle and the radius, and it's 1/3 of a cylinder, so that would be a cone. All right, right now, volume is given to us in terms of the radius and height. We want the height in terms of the volume and the radius. So why don't you pause it and try this one on your own. Clear the fraction first. All right, let's check our work. So to clear the fraction, I would multiply both sides by 3. Okay, now I'm left with 3v equals, these are going to cross cancel, the 3's, equals pi r squared h. Now we have to get h alone. So this is what I call a twofer. We can get rid of pi and r squared at the same time. Since they're both multiplied by h, we're going to divide by h. Divide by r squared, pi r squared, sorry. Multiply. We're doing the inverse of what pi r squared is doing. So since it's being multiplied, we have to divide by what we want to get rid of. Pi r squared on both sides, and it will cancel here, and so we're left with 3v over pi r squared equals h. Now h is given in terms of the volume and the radius. All right, the next formula is given to us. It's about the conversion of Fahrenheit to Celsius. F is given in terms of C. So the first thing we're going to do is, it's easiest to undo the addition and subtraction. So subtract 32. Now, I don't just want to get rid of the 5 in the denominator, I want to get rid of the 9 too. So we can do that all at once by multiplying by the reciprocal of that fraction. Remember, we're basically just multiplying both sides by the reciprocal of that fraction. We can do anything as long as we do it to both sides. Now over here, we can just leave it as 5/9 f times the quantity of f minus 32. You don't even need to distribute it. Cancel, cancel, boom. If you want to distribute, you can, but you can leave it like this. Okay, except then flip it around. Sorry. And we're done. Just get what you're doing alone. Okay, get the C alone and stop. Because when you distribute that 5/9 to the 32, you may have an error. So we're okay as long as we get it all alone. All right, next one. This is an interest. This is the total balance is equal to the principal plus PRT stands for interest. Sorry, principal plus the interest. So P is for principal, but principal rate and time equals interest when you multiply them together. So we have to get that little r. So with multi-step equations, it's always easier to undo this addition and subtraction. So I'm just going to get rid of this giant P first. And then I get T minus big P equals big P RT. Now we're going to divide both sides by capital big P little t by big P little t. Don't cancel on this side. Just leave it alone. Because you're canceling, you don't really have the skill to truly equals R. Just stop right there. We're only canceling on this side because we need to get it alone. R equals big T minus P over big PT. Now what this really means, why I said don't cancel, you can't just cancel the P's and you can't cancel the T's because the big T stands for total, the little t stands for time. And you can't take a piece of a binomial, and this is a binomial, two terms. So we can't take just that P out right here. So leave it alone, don't simplify it. What this really means is T over PT minus P over PT. So if you were cross-canceling, you could do it here, and then you'd be left with this, T over PT minus 1 over T. But that's pretty complicated. I'm telling you, just stop here. Don't try and simplify it. You're going to make a mistake because we just haven't had the training yet. By the end of the book, you will be simplifying things like that. So just stop. Once your variable's alone, stop. Don't try and simplify it. Okay, now R is given in terms of T, R and P. Okay, this time we're getting the big P. This is kind of a lot for you guys, considering we really haven't done much factoring. So really the biggest thing that we could do is factor first. Okay, if I factor out the P, I think Ms. Cacciatore taught basic factoring. Now what I can do is I can divide both sides by this chunk, 1 plus RT. Remember, it's all multiplied by 1 plus RT. So I'm going to divide, and now I'm left with big P equals T over 1 plus RT. All right, this is similar. Similar. Once you pause it and try it on your own. Factoring is involved. All right, let's check it. What do both terms have in common? An x. So let's factor an x out, and then we'd be left with b plus c. So if I divide an x out, if I pull an x out of here and an x out of here, we place it here. What's left is just the b plus c. And now we can divide both sides plus b plus c, divide both sides by b plus c, and a over b plus c is equal to x. Go back to the PowerPoint, it looks prettier. Turn it around, now a is given, x is given in terms of a over b plus c. Okay. Sorry. All right, next. This is sneaky. Okay, so when you need something out of a denominator, a piece of a denominator, first just get it out of the denominator. make it so it's out of the denominator. So since this is being divided by x plus y, let's get x plus y out. Instead of dividing by it, let's multiply both sides by x plus y. Now we can cross cancel, right? And so we are left with 1 equals x plus y times a. Now, we could divide both sides by the a now, get rid of the a. Or I think I would, okay, they're distributed. You could do one of two things. We could divide the a out and then subtract the y, or we can distribute it, then subtract ay, and then you could divide all terms by a. Now, this is equivalent to, let me show you another way. You could have right here, since a is being multiplied, you could have divided both sides by a. Okay, and then you get x plus y equals 1 over a. And then subtract y, x equals 1 over a minus y. This is really, these are equivalent statements. This is just reduced. I would accept either. Just remember that when you divide by the when you get your variable, don't try and reduce it. Okay? Not yet. Not at this stage in your development. And that, my friends, is our lesson. So, that's it for the day. See ya.